Oh. ಹೇಳಿ. ಹ್ಞೂ ಎಲ್ಲಿದ್ದಾರೆ? ಅಲ್ಲ, ಮಾಡ್ತಾ ಇರಿ ಅವ್ರನ್ನ. ಜಸ್ಟ್ ಟಾಕ್ ಟು ದೆಮ್ ಬೈ ಅರೌಂಡ್ 5 o'clock. ನಾನು ಮೀಟಿಂಗ್ ಒಂದು ಕಳಿಸ್ತೀನಿ ಅವ್ರು. ಹ್ಞೂ Hello, is the PDF visible?
Yes, but your voice is echoing.
Hello.
It's correct. PDF is not visible, sir. White blank screen. Now it's visible, sir.
ಓ, ಸ್ವಲ್ಪ ಹೋದಾಗುತ್ತಾ? ಸರ್ ನಡೀತಾ ಇತ್ತು. ಲ್ಯಾಬ್ ಮಾಡ್ತಾ ಬಿಡೋದು. ಎಷ್ಟು ಸಮಾಚಾರ? ಹಾಂ, ಮೀನಿಂಗ್? ಹೌದು. ಹೌದಾ? ಹ್ಞೂ ಎಲ್ಲ ಇತ್ತು. ಹೌದು, ತೆಗೆದು ಬಿಡಕ್ಕೆ ಕಾಣದಂಗೆ ಇಕ್ಬೇಕು. ಕರೆಕ್ಟ್. Again. I don't know why it is taking such a long time. Sorry for okay. Hello, is my slide visible? One of you unmute.
Yes, sir, it's visible.
Hello.
Sir, it's visible, sir.
Hello.
Hello, am I audible, sir?
Yeah. So is my slide visible? PDF.
No, sir.
Just a
It
minute.
was earlier.
It is taking a lot of time over here. Just a minute. Oh, why it goes off? I don't know why it goes off.
Yeah, now it's visible, sir.
But for me, where is one second.
Yes.
Okay, Cisco WebEx. Why it goes off? Okay, now this slide is visible, no?
Yes, sir.
Yeah, fine. Okay, that's perfect. Let me just make this. Okay, now we are. Sorry for the delay. So because of a lot of, I think my system has become slow. Okay, this is at L293D. If you can see here, so let us go to. Okay, this is what it has. It has got 4 buffers. Can you see here? 1A, 1Y, 2A, 2Y, 3A,
3,
3Y, 4A, 4Y.
4,
A
1.
all inputs, Y is the output. Can you
Yes,
see
sir.
each one of them have been connected to one pin which is called as enable.
Enable pin.
If this
Yes,
is
sir.
high, it will enable both the buffers. If this is
Yes,
made
sir.
high, it will enable these 2 buffers. Correct?
Yes, sir.
1, 2 enable means it will enable this. It's an active high enable, meaning if you want to enable these 2 buffers, you have to make this 1. That is VCC. Otherwise, it won't. Even though if you give something over here, nothing will be coming here. It will be in high impedance mode. Meaning, if you give 1 here, it will not be 1 as long as this is 0. As long as this is 0. When I say 0, 0 volt. Let me just go to of course, this is how the pin diagram looks like. Can you see this is pin diagram? 1,
Yes, sir.
2 EN. This is enable.
Enable.
1A, 1Y.
1, right.
These are 2 grounds, heat sink and ground. Heat sink and ground means, okay, if you want to take out the heat from this IC, so a heat sink will be connected to this and grounds will be connected over here. For each of the buffer, there are grounds. So you can see you have got 4 buffers. That's why there are 4 grounds. Why you
Yes, sir.
have ground means because it is a buffer IC which will going to source the current as well as sink the current. Let me just come to that. Okay, what is that source and sinking the current? Can you see here some description?
Yes,
Pin
sir.
number 1. This is pin number 1. So it is. Can you see this type? Type is I. I stands for input.
Input.
So it enable drive channels 1 and 2. It is active high input.
Yes, sir.
Of course, whenever you want to use any of the ICs, first and foremost thing is that you have to download the data sheet, understand what it is. Can you see here? And next the name is let me just
1.
1 to 4. This is 1 is to 4 means from 1 to 4A. So these are all inputs. There are 4 possible inputs. The pin numbers are 2, 7, 10, 15.
Okay.
They're all input. It is driver input. They're all non-inverting mode. When I say non-inverting, if you give 1, you'll get 1 only. If you give 0, you'll get 0 only. Correct?
Yes, sir.
And then you can see there are 4 outputs. Y stands for output. And you can see the pin numbers are 3, 6, 11 and 14. So O stands for output.
Yes,
Type
sir.
is out. Then you can see driver outputs. Done. This is
Yes,
again
sir.
3,4 EN enable pin number 9. It will enable channel 3 and 4. Okay,
Yes,
we
sir.
discussed this so and so. And then you can
Ground.
see VCC1 pin number 16. Maybe in the Tinkercad you have supply 1, supply 2 or power
Yes,
1,
sir.
power 2.
Yes, sir.
Power 1 is this VCC 16. You can see 5 volt for internal logic translation. When
Yes,
I
sir.
say logic translation, whenever you're giving high, you have to get high no. So for that you have this 5 volt or whatever voltage. If you give higher, it should enable that. Okay, output will be high. Next you can see this is VCC2, which is power
Power supply, sir.
VCC for drivers 4.5 to 36 volt. This IC, even though the supply voltage can be 5 volt, but it is capable of handling
Up to
4.5 to
36.
36 volts, meaning you can have any loads which can drive
Range
with a
between.
voltage of 36 volts. 36 volts.
Moon. Yes, sir.
36 volts. This is about the pin numbers. Can you see these currents here? Some absolute current ratings.
Yes, sir.
So here output supply voltage is 36. Supply voltage, of course, this can also be 36 here. It can go up to 36.
36. Can give
This
us.
is for okay natural ground. Okay, forget about all these things. Input voltage can be up to 7 maximum. These are all maximum things because
Yes,
these are
sir.
all absolute maximum ratings. See here, one is output current. It can, okay, this is peak current I naught, it can see here minus 2 and 2.
Yes, sir.
Minus 2 and 2 means, okay, this is minus 2 current which it can sink. 2 amperes of current it can source. Because usually when you're taking a motor, no,
Yes, sir.
I don't know okay, whether you have noticed it or not. So those who are having what is that? UPS, uninterrupted power supplies.
Yes, sir.
Does UPS is connected to your geyser? Does UPS is connected to what is that? Washing machine? Does UPS is connected to your what is that? Motors? That is
Yes.
okay. Pumps, are they connected?
Yes, sir. Yes, sir. We can use to all
Now
of
my
them.
question is, if main power goes off, does your water heater at your bathroom, can it be turned on?
No, sir.
Can
It
somebody
requires more energy.
more energy? Okay, what do you mean by more energy here?
It drives. It requires lots.
It requires sort of
Uh, uh, the power supply should be greater than usual, sir.
like how much? More than
If
230
they use
volts?
no, not like that, sir. More than the UPS providable energy.
Meaning,
Like,
because we have some loads. Shall we say a tube light in your house is a load,
yes,
fan
sir.
in a house is a load, even the
Yes, sir.
geyser at your house is also a load to your supply.
Yes, sir.
They
It
are all
is.
loads.
Yes, sir.
Why UPS can drive a bulb? Why UPS can drive a fan? Why UPS cannot drive a geyser or a motor?
The load of bulbs and fan is lesser.
What do you mean by load now? What do you mean by load?
Uh, the, re- uh,
That's
the
what is
amount of power required to run it out.
again. What do you mean by power now? So power is actually given by voltage multiplied by current.
Yes, sir. VI.
You can see all of them require 230 volt, but the power will be more. Maybe for your what is that? A bulb,
Agreed, sir.
it can be 40 watt, it can be 9 watt, it can be what 100 watt. You can see it is in terms of watts. So
Yes, sir.
the required amount of current is in terms of less than 1, or it will be less than 1 ampere.
Yes, sir.
Whereas for a motor, how do you can somebody talk? Okay, what will be the
HP,
motor ratings?
HP, half HP, 1 HP.
1 HP corresponds to how much watt? Your BEL question.
Sir, 746.
746 watt.
Yes, sir.
746 watt. Watts?
Yes, yes, sir.
Yes, sir. What, sir? What?
Suppose if you say it's a 1 HP motor, if it is 230 volt, how much current does it require? It is whatever 376. Okay, what is 1 HP is equal to how many watts? 7?
746.
Yes,
746
746, sir.
divided by 230
146.
will be how much? Will it be more than 2 amperes?
Yes, sir.
Yes, sir.
3.10.
Yes, sir.
You can see it is 3.13 amperes. Suppose if you connect that to your UPS, to which battery is supplying the required amount of current, you can see it will dry out so soon,
Yes, sir.
because whatever that is stored in your battery is some charge is stored. When you are drawing more current, what will happen? It will dry out soon.
Yes,
So
sir.
that's why you will not connect any high current drawing loads to your UPS.
Yes, sir.
So likewise, if you can see here, why I'm just telling all those is, see, peak output current does this can deliver is 2 amperes of current. Can you see it can deliver
Yes,
2
sir.
amperes of current?
Yes, sir.
So, of course, it is not in terms of milliamperes. You can able to drive a
Yes,
motor
sir.
using this IC, that is L293D. Have you seen any other ICs prior to this particular? Have you seen any ICs so far?
Yes, sir. For and OR gate.
Have you seen that 7408, 7400, all those things?
Yes, sir.
If you
In
see
such a new
them, their current ratings are in terms of hundreds of milliampere, not more than 300, 400 milliamperes, because
Okay.
their loads are always simple LEDs or one more IC.
Yes, sir.
They won't draw too much current, but this IC, which is exclusively meant for driving motors. Can you see here what is the specification? What is the description of this? If you can see the description of this thing, can you see the application? Stepper
sir.
motor driver, DC motor driver. Can you see here? This
Latch.
is used to drive motors.
Yes, sir.
This can you can see bidirectional currents up to 1 ampere at a voltage of 4.5 volt to 36 volt. So this is the current it can able to provide. So whatever we are showed there is the maximum current, 2 ampere.
Yes, sir.
This is the typical current, 1 ampere it can easily deliver.
Yes,
So here,
sir.
that's what is here. Output current 1 ampere per channel. Per channel.
Okay.
This is
Yes,
output
sir.
current. This is peak current per channel. So because we have something like average current and peak currents. So peak current will be there sometime. So it will not be there throughout.
Yes, sir.
Okay, if you are looking for L293D, then the current is 600 milliampere. Can you see this is L293X?
Yes, sir.
This X can be different. It can be D, of course. That you can. Can you see here? Can you see this?
Yes, sir. Any.
NE is there, DNE is there. Now this is how this is for the package. And if you look at the data sheet over here, I don't know where, maybe in this case, no, this is, I don't know it is for which one. Okay, it will be specified here. Can you see here? This is just, there is no D here, there is a D here.
Yes, sir.
Okay, let us go to source and sink. Just try to understand this. Okay, what I can make you here is, okay, let me just, so that you can able to understand. 1 second. You can see, yeah, fine. Can you see this?
Yes, sir.
We have 4 buffers driving 3 motors.
Yes, sir.
See here?
Yeah.
Buffer 3 and 4 are driving only one motor, correct?
Yes, sir.
And
But,
can you see this? This is exclusively 4 is running this motor, 3 is running this motor, whereas
sir.
buffer 1 and buffer 2 are driving a single motor.
Yes, sir.
See the direction here? Clockwise.
Yes, sir.
See the
These are
direction here?
clockwise.
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 Here,
It's both clock and
clock
anti-clock.
as well as anti-clock.
Yes,
Meaning,
sir.
if a
By
motor to run, this can be, of course, you can see if you give 0 here, If you give 0 here, it will halt.
Yes, sir.
If you give
Stop.
1 here,
It will
this
start
whatever voltage you have in this VCC2, that will be going to this. That will be going to this. Then it will run.
Yes, sir.
It will run here when you make it 1. If you make it 0, this will halt. Come down
Yes,
here.
sir.
And you can also notice this. This is made 0, 1 permanently. Can you see this is
Yes,
made
sir.
1 permanently? It is not coming down here.
Yes, sir.
Why it should not come down? This is what 9? Enable for 3 and 4.
Yes, sir.
You should enable all of them for the entire period of your
Okay.
experiment. So that's why it is made 0 and then 1. Whereas this
Yes, sir.
can be made either 0 or 1 depending on whether you want to run the motor or not to run
No.
the motor. Then come to this. If you make this 1, 30 whatever voltage VCC2 is there will come over here. If you make this 0, whatever VCC2 that will come over here will, of course, the current will pass through this in this direction and then has to be synced. Now you can see it is sourcing. This is sourcing and it should sync. So
Yes, sir.
now this is acting like source, this is acting like sync, because now this is sourcing. When it is 1, this will source. When it is 0, it will sync. Assume
sir.
that if the current has to go in the from bottom to up, what should happen? This should
This
become
will reverse
1,
of it.
that should
That is
become
0.
0. This
This
should
is source and
source,
sync.
that should sync.
Yes, sir.
Maybe let me go to the circuit and then try to understand. This will going to help you.
Gain was.
Can you see here? This is output. This
Yes,
is again
sir.
output. Whenever I say it is high, it will source from VCC2 to this output. Can you see here the direction?
Yes, sir.
The current from VCC2 will come through this transistor and goes to output. It is now sourcing. In
Yes, sir.
syncing, you can see it takes the output current and then goes to the ground through this.
Yes, sir.
So this will going to sync as well as source. Okay, that way we can able to source as well as sync the current of. Okay, these are all, again you can see it is source and sync. How do you make it is? Can you say this here?
Yes, sir.
H.
Yellow. Okay, high end.
This
low.
is enable. Low and high, it will turn right. So depending on what is the direction you have. If it is H and L, turn left.
Left.
See if it is LL. If
Fast
both of them
motor.
are low, both of them want to sync.
Yes, sir.
If both of them are syncing, if nobody is sourcing, it won't run. So that's why motor
Yes, sir.
stops. If it is high,
Both are
both are trying to
sourcing.
source. Current cannot flow if the potential is same on either side of the motor.
Yes, sir.
That's why for high or low, motor stops. Whereas
Yes, sir.
for low and high and low, motor will going to run in opposite direction.
Yes, sir.
Okay, this
So
is.
basically, we can interchange sourcing and
You can.
syncing.
That's what. Otherwise, if you don't interchange sourcing and syncing, you cannot make the motor to run in both the direction.
Yes, got it.
The advantage here is that the output, whatever buffer you have, can source as well as sync. Source as well as sync. The amount of current it can source is almost equal to current it can sync.
It's going to sync.
Let me just show you. Okay, can I able to show that syncing current as well as sourcing current? That -2 was there, no? -2 was okay, like okay in the opposite direction. That is, it can sync up
Syncing.
to
Yes, sir.
maximum of -2 amperes of peak current. Average current is somewhere around
Minus
what
one.
is that? 1.2. 1.2. Where is that? Here? No, not here. Maybe somewhere here. Can you see this?
Yes, sir. Oh, minus 600.
This one. This is continuous output from L293D.
Okay, yes, sir.
This is L293. It can source 1 ampere of current. It can sink 1 ampere of current.
Minus. Sir.
And can you see this here? Can you see there are so many specifications non-repetitive. If the time period is less than 100 microsecond, if it is non-repetitive, you can have a current. Meaning you cannot make it switch on, switch off all the time. If you want to switch on, switch off all the time, it can sink hardly minus 1 ampere and it can source 1 ampere of current. When I say sink, you just say okay, sink or it can source minus 1 ampere of current. Minus 1 means it's actually sinking. Suppose that you are connecting a motor whose rating is more than what is this, then what will happen?
It cannot drive.
What will happen?
It won't run, sir.
No, it will run, but it just heats
At
up.
very low sir.
No,
Or at low speed, sir.
not at low speed. Let me just give you that. Okay, why sometimes ICs will burn? So sometimes ICs will burn, no? So
Yes,
assume
sir.
that how much is how much is 32 into, let me take it as 24 into 1 is 25 watt. Okay, let me take a current, sorry, let me take a motor which is of 25 watt rating, correct? So
Yes,
I
sir.
have a motor which is of 25 watts of power. This is a motor, this is 25 watt. I want to use L293D. I want to
Yes, sir.
use L293D IC. So from the data sheet, what is the maximum current it can source a sink?
Minus 1 point.
600 milliampere
Yes,
continuously.
sir. 600 milliampere.
That's what is there here. So that's how your data sheet will help. Can you see here? Continuous output current I0 is equal to, for L293D is minus 600 milliampere.
Yes, sir.
So what does this will say is, this can source or it can sink 600 milliamperes of current continuously, because this, if
Yes,
this
sir.
motor has to run continuously, it should be so and so. Assume that you have connected VCC2 of 25 volts, correct?
Yes, sir.
Suppose if this 25 watt is there, this is power, and if voltage is 25 volt, then what is the
Current
current?
required. 1, sir. 1 ampere.
1 ampere. Suppose assume that I connect this, what will happen? Okay,
Sir,
if it is so and so,
wait.
then
Yes,
can
sir.
you, can you tell me what is the resistance of this?
What is the resistance, sir?
Because I
1
know what
second.
is wattage, I know what is volt, I know what is resistance. Okay,
Sir,
now you know that it requires it requires 1 ampere of current to flow through. But what is the
yes,
rated
sir.
current?
600 milliampere.
What will happen suppose if I connect this motor?
It,
It will run, but
but
this
it
600
thinks fast.
milliampere is the continuous maximum current it can supply, but
Yes,
this
sir.
requires 1 ampere of current. So what happens, it is keep on drawing, at some time this will heat up and it will go off, it will burn.
Okay.
So
That
instead
means
of
if
that,
you're forcefully trying to pull more energy,
because resistance is less, you are trying
yes,
to
sir.
draw more than the rated current, what you have to do is you have to make sure that, so suppose if I make it 32 volt, will it be fine
Yes,
then?
yes, sir. 25 by 32 is lesser than 1 ampere.
No, will it be less than 600 milliampere?
No, sir. Still, it's 781.
Okay, still it is better. It may burn out bit later.
Yes, sir.
That's how I think. What is the rated voltage? Is it 36 or 34? How much is the rated voltage?
36,
36.
sir.
Suppose if you go to 36 volts,
25 by 36. Yes, sir. 690,
of
694.
course, now you can see that's how your voltage will play a role in making your IC safer.
Okay, yes, sir.
Okay, so you can just play with that. Of course, you can't play with these things in your Tinkercad. Tinkercad, of course, it will help you to at least to understand how it works. But if you want to really have the hands-on, so you may have to come to lab and then try experiment out all these things.
Sir, here they have mentioned input voltage VI, right, sir?
Where? Okay, here.
The third one.
Okay.
Where it is, we had the
Input
range was
voltage
0 to
that you
5
are
volt.
applying to that buffer input.
That's we said 5 volt, right?
5 volt
Maximum.
is the typical voltage. These are all maximum ratings. Max.
Okay, sir.
This is maximum 7. Okay. Maybe now we'll go to lab and then try to demonstrate that motor running, and it's fine. Hello, is it visible?
No, sir.
Just open. ಮತ್ತೆ ನಂದು share ಮಾಡೋದು. ಇಲ್ಲ. Okay, is it visible now?
No, sir. The PDF is shown.
Oops. Yeah, it's coming. Participants ಹೋಗಿ
ಐ ಥಿಂಕ್ ಅವ್ರ ಸ್ಕ್ರೀನ್ ಅಲ್ಲೇ ಮಾಡ್ಕೋಬಹುದು ನಮ್ಗೆ ಕಾಣೋದಕ್ಕೆ ಕ್ಲೋಸ್ ಆಮೇಲೆ ಬರುತ್ತೆ ನನ್ನೆಲ್ಲ
ಪಿನ್ ಮಾಡೋದು.
ಇಲ್ಲ ಸರ್ ನಾರ್ಮಲಿ ಎತ್ಕೊಟ್ರೆ ಬಂದು ಕ್ಲೋಸ್ ಮಾಡ್ಬಿಡೋದು ಸರ್ ಸಿಸ್ಟಮ್ ಓಪನ್ ನಿಮ್ದು ಸಿಸ್ಟಮ್ ಕ್ಯಾಬಿನ್ ಅಲ್ಲಿ
ಅಲ್ಲೇ ಓಪನ್ ಆಗಿದೆ.
ಅವಾಗ ಬರೀ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಬರುತ್ತೆ
ಕ್ಲೋಸ್ ಮಾಡು. Something visible?
No, sir. Not yet.
Hello.
Yeah, now it's visible, sir.
Is the circuit visible now?
Sir, it's a bit shaking.
Yes, sir.
Okay, now can you see the Arduino? This is how
Yes,
the
sir.
Arduino looks like. So this is Arduino Mega. This is not like Uno. So Uno has got limited number of pins, that is 14 digital IOs and 6 analog inputs.
Inputs.
But here in this Mega, so it has got 53 digital IOs and there are 16 analog inputs. It has got a bit extended number of analog and digital input and outputs. The circuit is, I think I have shared the circuit. What is, can somebody, what I have is, I have a slightly different circuit than what I shared in your. Okay, this is circuit what I have, what is implemented. Can you see the circuit?
Yes, sir.
If you can see the circuit, we have a toggle switch. Can
Yes,
you
sir.
see? I have a toggle switch. This is switch 1. This is switch 2. This is how a toggle switch look like. Can you see that toggle switch?
Okay. Yes, sir. We used it in
There are
first problems.
3 pins, and of course the extreme one are just the what supporting thing. You have 3 pins. Can you see those 3 pins?
Yes, sir.
Middle one and the 2 extremes, and of course the 2 extremes are just the clipping things. Correct?
Yes, sir. Middle
Uh,
clip.
You can also observe. Can you see this is movable? I can able to move this to either right or left, up or down.
Yes, sir.
I can able to make it go up and then, or I can make it to come down. It is exactly now. Is it in sync or is it going off sync?
Sir. Didn't get you, sir.
Hey, Subramania, Sumjavani. Can you see this now? Connection? One of you respond.
Yes, sir, it's visible.
Okay, fine. Can you see there is switch 1, switch 2? They are exactly these 2 switches. Say yes or no.
Yes, sir.
Pin madakala. Pin madabodalla. All of you simply keep on watching. Don't operate anything. Pin ಮಾಡೋದು ಯಾರಿಗಾನ ಗೊತ್ತಾ?
Yes, sir.
Just observe the connection there. Can this switch 1 switch out to output be 0 on VCC? Vinut Anna.
Yes, sir.
Vinuta, yes, speak out. Vinuta, yes.
Sir.
Can you see this SW1, SW2 what you have? Can it be going to VCC or ground?
Yes, sir, it's going to VCC.
If it is VCC, it is high. If it is ground, it is low. Am I correct?
Yes, sir.
Fine. It is the same case here also. Am I correct?
Yes, sir. Yes, sir.
See, if this is high and if this is low, can this buffer, will it source the current and will it sink the current?
Yes, sir.
Assuming that this is sourcing and if this is sinking, we will assume that the direction of motor rotation is clockwise.
Okay, sir.
Done?
Yes, sir.
Now, when this is high and low, that is when I just make this low and this is high. If I make it both of them high, what will happen? Both of them are trying to source.
Yes, sir.
What will happen then?
The motor will not rotate.
Motor will not run because here also it is 12 volt, here also it is 12 volt. There is no potential difference across the two ends of the motor. It will not run because current is not flowing.
Yes, sir.
Correct?
Sir, it's echoing, sir.
Echoing. ಇವತ್ತಿದು ತೊಲಗಿ ಇಲ್ಲಿಗೆ ಹಾಕು. ನಾನು ಮಾತಾಡ್ಬೇಕಾ? ನನ್ನ ಮಾತು ಕೇಳುತ್ತಲ್ಲ.
ಅಲ್ಲಿ ಸ್ಪೀಕರ್ ಬಂದಿದೆ ಸರ್. ಚಿಕ್ಕ ಮೊಬೈಲ್ಗೆ
ತಾಳ್ರಪ್ಪ ನಿಮಿಷ. Okay, let me just demonstrate how it happens. See, okay, these are the. So we have connected this to black means it is ground. The middle one is output, that is either it can go to VCC or ground depending on the switch position. And this is left side is VCC. I have got ground, VCC on either side. The middle one is going to your what is that? Arduino. Can you say this now? One is going to VCC, other is ground. The middle pin is going to your buffer input. Likewise, we have got two switches. Just have a look at these two switches. These two are the switches. So you can see one of them is connected to black. This is black, and this is the extreme left or red. And of course, the middle one is going to your two buffer inputs. See here. Both of them are on one side, meaning it is now 0, 0. Now we can see is it connected towards the black side? Since it is connected towards the black side, it is 0, 0. What I'll do, I'll make one of them high. Just have a look at the motor rotation. Can you see motor is now stopped? Now I'll make one of them high and I'll again make it 0. So the program is written in such a way that whenever one of them become high, it will run for 10 seconds. You can see, I'll repeat it. I'll just make it 1 and then make it 0. Now it is keep running for 10 seconds. That's what your program says. Okay, 5 seconds. Now, if I redo it, suppose what I mean by redo is if I make the other one high and low, can you see it actually rotates in the opposite direction? Because maybe you can, could you be able to notice that rotation clockwise, anti-clockwise?
Yes, sir.
Let's just show you that again. See this, just see how it runs. It is running in one direction. See now, is it going opposite?
Yes, sir.
You can see here, we are using one power supply. This power supply is used to VCC2. Can you see this is 12 volt? This is actually 12
Yes.
volt. And the other one, that is VCC1 that is required, we got it from your Arduino side.
Can you see this pin number 16? Pin number 16 is going to this orange, and this orange is ultimately going to pin number 5. Sorry, not pin number 5, the power supply of 5 volts. So we will have a look at that code also. Okay, let me share the code. Okay, can you see this?
Hello. Can somebody unmute? Subramanian?
Yes, ma'am.
Just keep reading the line by line code. मतलब reading मतलब try to understand that. Can you see button 1, button 2? They are assigned to pin number 8 and 9. Correct?
Yes, sir.
Yes.
Hello.
Yes,
Can
sir.
you see output 1 and output 2 are assigned to pin number 4 and 5?
Yes, sir.
And you can see there is a 2 integers defined B1, B underscore 1, B underscore 2. They have been assigned to 0, 0.
Yes, sir.
Say yes or no.
Yes, sir.
Mark का मता ही नहीं, no. Okay. Then come down. Pin modes. Is it fine? Just know the pin. Hello. Can you make out this pin modes? Pin mode अर्थ आयते ना पा? Hello. One of you respond. Hello.
Yes, sir. Yes, sir.
Just come down here. B1 is assigned with digital read button 1. B2 is assigned with digital read button 2. What does it mean? Hello.
We are going to read the state of buttons. Is it on or off?
You are actually putting the value of button 1, button 2 onto B1 and B2. Correct?
Yes, sir. Yes,
If
sir.
B1 is high and B2 is low, now you are logically checking the condition. This and this is double ampersand is and.
Yes, sir.
Correct? If
sir.
both the conditions are true, you digital write output 1 with high and output 2 with low. Can you see now one buffer is made high, the other one is made low?
Yes, sir.
What will happen? The motor will run in a particular direction till
Yes.
5 seconds.
Yes, sir.
Till 5 seconds. And then you can forget about this particular part of the code. We are not implementing that. Just come down here.
Yes, sir.
The read values, digital read values, if B1 is low and B2 is high, just see what is the digital write of out and out 1 and out 2.
It's inverse of it.
Are they exactly opposite to the first case?
Yes, sir. Low.
Now what will happen now?
It run in the opposite.
The buffer which was sourcing, now it starts syncing.
Yes, sir.
The one which was syncing, now it started sourcing.
Yes, sir.
So since it is in an infinite loop, and of course we have made when it is low and high, none of the conditions are true. When none of the conditions are true, because you will initialize the value of 0, 0, so
Yes, sir.
off.
Yes, sir.
Correct?
Got it.
Shall we give some task?
Yes, sir.
When you actually left SIT, was that automatic door opening was there installed in the administrative block?
Yes, sir. It was there.
Was there? Can you people implement that? It is far superior than what I'm showing here.
Yes, sir. It's automatic.
Here, let me just show you what is how does our thing is working. Now this is something like this.
We use some sensors, right?
That's what I want you people to use the same. Is this fine now? Is it visible?
No, sir.
See that. Now this is your door. Now this is assume that this is switch 1, this is switch 2. The way how we have implemented is this is only one way. That's what we have implemented. Meaning when a person enters this, so we are assuming that this will go high. This will go high and it will again come 0. It has gone high. It's like okay, it's like a push button. It's like a push button. Whenever he puts his leg on this push button, it becomes high. Whenever it takes out, it will become low.
So it's not visible.
How about now?
No, sir.
How about now?
So it is visible in another screen, sir. The shared content is on another screen, and
It's
you're
not in
showing
shared
on
content.
screen.
It's in
Yes.
my what is that? My window.
Yes, sir.
It's not the shared content. You just search for where it is visible. Is it high whenever I press the button and then whenever I put my leg on this button, when I take out this, it will become low, correct?
Yes, sir.
Meaning, can you see now when this is high, assume that it's a one way, one way, and people are allowed to move in at a very slow rate. So one person has touched this, it has become high. During that time, it is low. So it is first initially it is low, correct? When
Yes,
it
sir.
is low, to assume that this door was closed, it will be there in the closed condition, correct? When a person enters this, this becomes high, this becomes low. So mean this is started opening. This has started opening. So this will happen for a very fraction of a time, because whenever he puts his leg, it is high and low. Whenever it takes out, it is still low, correct? It won't stop immediately because you are having a delay of 5 seconds, correct? Take out.
Yes, sir.
As per my program, once it becomes high-low, motor will run in particular direction for 5 seconds, irrespective of the condition.
Yes, sir.
Then, of course, automatically before 5 seconds, it will become low. It will become low. Then motor will not operate. Meaning, if it has opened, the door is in still open condition.
Yes, sir.
And whenever a person leaves this part of the door or this part of the path, he again presses this. When
Yes,
he
sir.
presses this, does this become high? This will be still low because no person has entered here yet.
Yes, sir.
So when this is low high, meaning that that person has left that particular zone.
Yes,
So
sir.
does the door has to close now?
Yes, sir.
So since the door has to close, the motor which is connected to this door will actually move in the opposite direction.
It will close. Yes, sir.
For how long? Again for 5 seconds.
Yes, sir.
And of course, this is not this program what we have written is not applicable for two-way movement.
Yes, sir. Single one way amount only.
It is only one way. And it is not for multiple entries also.
Yes, sir.
Because if that more number of students or more number of people are want to cross, So it will not consider.
Yes, sir.
So I want all of you to improvise on the very basic code that what we have written. Even if n number of people are coming from one direction, those should not close even if that other first person leave that other end of the door or other end of that zone. Getting the point?
Can you repeat again, sir?
See, just assume a practical scenario where assume that a set of students want to go out of that administrative block. Let's open. It should be in open condition as long as people are moving in that region.
Yes, sir.
So it should be kept on. It should not be, the motor should not run in the opposite direction. When does motor should run?
When the person
There is
leaves it.
signal from either of the boards, from either of the buttons.
Okay, sir. Huh.
If you want to make it bi-direction, if a person comes from left to right or right to left, it should open. First thing should be, it should open whenever it is closed.
Yes, sir.
So just consider all those practical conditions and then try to implement that using Tinkercad. Of course, the same thing can be implemented in Tinkercad. We want to just show you, okay, how does that motor runs in actual scenario. So we just implemented that. What is that?
Switch.
This is one switch, which is toggle switch. Maybe I'll also show you that button. Push to on. Push to on is a different switch. I think the one which you that way you can use that push to on button, no?
Yes, sir.
Can you see this? Can you see this?
Yes, sir.
This is a button where I can push. Can you see? I can able to push this. Can you hear that sound? Tick tick.
Yes, sir.
Actually, what happens is now it is open. So there is no connection from. Is open. Press one. Press.
Continue to use. Continue.
Now this is a push button. This is a push button. Okay, these two are maybe in your Tinkercad you have 1A, 2A now.
Yes, sir. 1A, 1B, 2A, 2B.
And 2A, 2Bs.
Yes, sir.
So maybe A is one switch, A is one switch, B is other switch. These are the two ends of A switch. These are the two ends of B switch. There are actually two switches. If it is in open condition, that is, if it is not pushed, this 1A and 1B are open. It's something like this. So you have no. Let me write it like this. This is like, okay, 1A, 2A. This is 1B, 2B. This is, okay, simultaneous pushing is there for both of them. Can you make out this? This is actually 1A, 2A. sorry, this is 1B, 2. This is switch A, this is switch B, correct?
Yes, sir. Yes, sir.
This is switch A, this is switch B. Now I have a single button which will press both of them simultaneously. Can you see here?
Yes, sir.
I have a single button. I don't have two buttons. I have a single button. If I press, both will get connected. That is, 1A, 2A will be connected, and 1B, 2B will be
Yeah.
connected simultaneously. Now,
Yes, sir.
in normal condition, both are open. This is 1A, 2A. This is 1B, 2B.
One way different.
Both are open. When I press it, both will get closed. That is, these two will be shorted. These two will also be shorted. That we can notice here. So we have a multimeter. See, now we are trying to see the continuity of this. So this is 1A, maybe 2A. Now it is open. When I press it, just listen to that sound. Are you getting the sound?
No, sir. Yes, sir. Now what?
Okay, it has to come to your house now. And now if I remove it, went off.
Yes, sir. Now
Is
it
it?
comes. Sir. Yes, sir.
This is one switch. There is one more switch. Make out?
Yes, sir.
Both type of switches are there in your Tinkercad.
Yes, sir.
In your Tinkercad, you have a what is that? Push button, which is something like this, and you have one more slide switch.
Yes, sir.
Am I correct?
Yes, sir. 3 buttons.
So we have shown both of them.
Yes, sir.
Okay. How do you represent this? This is like a push button switch. Push to
Yes,
on,
sir.
we call it. This is push to on.
On.
If I push it will turn on. Turn on matlab will be get shorted. How
Yes,
about
sir.
this?
Slide
This
on.
is like, okay, this is slightly different. This one is something like this. Correct?
Yes, sir.
How do you, again, I'll just leave it to you people. You can either use push button or this. If you are using a push button instead of this, if you are using a push button, then how it look like? It is something like this now. Others?
Yes. Getting, sir.
Can somebody talk? Hello?
Yes, sir.
Hello? ಯಾರಿದ್ದೀರಪ್ಪ? ವಿನುತಾ? ತೇಜಸ್ವಿ ಶರ್ಮಾ?
Yes, sir.
Yes, sir. Yes, sir.
बहुत बार yes कह दिया. Okay, now, if this switch is in this normal condition,
So your voice is breaking.
Hello?
Sir, and also echoing.
How about now?
So still echoing, sir.
Okay. So if this switch is in normal condition, that is, if it is not pushed, what is SW1 voltage?
So voltage 0, sir.
Why?
So it's grounds and it's open circuit.
Perfect. So it will be 0 when it is open. If I push it,
Yes. So then, so 5 volts, sir.
why?
So it's connected, so 5
You can
volt
see
and
this
grounds.
is like okay, connected to 5 volt. So even
Yes,
though
sir.
this is there, whatever current flows, the entire voltage will drop here. You will get 5 volt. Meaning,
Yes, sir.
if it is open, it is 0 volt. If it is closed, it is 5 volts.
Yes, sir.
Is it exactly the same way here, like your
Yes,
slide
sir.
button?
Yes,
If
sir.
you push it up, it is high. If you push it down, it is low.
Low, sir. Yes, sir.
Here you need to operate both high and low, that is right or left or up or down. But here, if you're pressing, you'll get 5. If you won't press it, it will be 0 volt.
Yes, sir.
So the modification from slide switch to push button is this. So this will go to whatever buffer pin number, whatever you have, 8 or 9. So this will go to that. Correct?
Yes, sir.
This is like a more realistic circuit where somebody just puts his leg on this button, it will going to press and you'll get high. If he has not entered the other portion, it will be low. It is high, low, motor run in particular direction. When he leaves this particular button, this will become 0, 0. When it becomes 0, 0, after 5 seconds, it stops.
Yes,
Then
sir.
when he goes to the other end of the door, he will put his leg on this. So when he puts
Yes,
his
sir.
leg, the motor will run in the opposite direction. When he goes out, this will become 0. This is already 0. The motor will halt after 5 seconds, after 5 seconds or whatever the specified time.
Yes, sir.
Now, my question is, or you may have to just come up with some programming changes or maybe think of some different sensors. If people are keep coming here, it should be still, once it is get opened, it should not close unless there are no people over here.
Yes, sir.
Correct? That is one part. And then in the second part, you can just think of making it bi-directional. Whether the people come from either right or left, the motor should or the door should open if it is closed.
Yes, sir.
Correct?
Yes, sir.
Okay, who are all there? Let me ask some questions to all of you. ಯಾರಿದ್ದೀರಾ ಪहिले? Yeshu Lakshmi, what did you understand from all these things? I think you don't have any class now. Do you have any class? Hello, am I audible?
Yes, sir. Audible.
Yeshu Lakshmi, ಮಾತಾಡಿ. Are you there in the class? Or just
Yes,
joined?
sir. Hello, hello.
Hello.
Hello, yes, sir.
ಏನು ಅರ್ಥ ಆಯ್ತು? Did you get something?
Yes, sir, yes, sir. Sir, am I audible?
You are. Tell me what all thing you understood.
Hello?
What do you mean by sourcing and syncing?
Hello?
ಅಮ್ಮ ಕೇಳುತ್ತಮ್ಮ, ನಿನಗೆ ಕೇಳ್ತಾ ಇದೆಯಾ ನಾವು ಮಾತಾಡೋದು? ಹಲೋ ಯಶು ಲಕ್ಷ್ಮಿ. Okay, Yashaswini HM.
Sir?
Yeah. What did you understand by sourcing and syncing?
Sir, sourcing means when high source is applied to one buffer and low source is applied to another buffer, then then sourcing will takes place near buffering buffer 1 and syncing will at buffer 2. If high source is applied at buffer 2, then sourcing will takes place at buffer 2.
Okay.
Hello.
Okay. What is the maximum current does this L290 can source?
600 milliampere.
Maximum. Is it the overall or per channel?
Sir?
What do you mean per channel?
Sir, what, sir?
What do you mean by per channel sourcing?
Sir?
per channel sourcing, amma.
Sir, your voice is cutting, sir.
How many motors I can able to control using L293D?
So 4.
4. Both the directions?
Yes, sir.
Sir.
Can I able to make the motor to run in bidirection, all the 4 motors? Bidirection, how many I can control? 4 or 2 or 3?
Sir, 2, sir. 2 at a time, sir.
2 at a time.
Sir, if you're using
How about
bidirectional, then
Okay. Then you
sir,
can able to control only 2 motors.
yes, sir, because the second one will be in low, sir. It will be accepting, sir. The first one, which is in high, will be sourcing.
Maybe what I want is, do you have any quizzes scheduled tomorrow? Hello. No quizzes are scheduled, no? So you're all totally free. Hello.
Yes, sir. No quiz, sir.
No quiz, nothing. So I want all of you to write the code for what is this? Bidirectional motor. Hello.
Sir, we have DEC lab work also.
Lab work ಏನು ಮಾಡ್ಬೇಕು ನೀವು? Lab ಇನ್ಯಾವತ್ತು? Madam, when do you have
So submission is there.
ಏನ್ ಸಬ್ಮಿಷನ್? ಇದು ಅಷ್ಟೇ ಇಂಪಾರ್ಟೆಂಟ್. ಈ ಸ್ಲ್ಯಾಬ್ ಅಷ್ಟೇ, ಅದಕ್ಕೂ ಇದಕ್ಕೂ ಫುಲ್ ಮಾರ್ಕ್ಸ್, ಅದಕ್ಕೂ ಅಷ್ಟೇ ಮಾರ್ಕ್ಸ್ ಇರುತ್ತೆ. ಈ ಸ್ಲ್ಯಾಬ್ ಏನು 3 ಬರುತ್ತಾ? What submission you have? Hello. What submission you have? ಯಾರನ್ನ ಒಬ್ರು ಮಾಡುತ್ತಾನೆ, ನೀವು ಯಾರದು? ಹಲೋ. ಹಲೋ. ಏನು ಮಾತಾಡೋದು ಯಾರಿಗೇನು ಕೇಳಿಸಲ್ಲ? ಸಿಂಧುಶ್ರೀ.
Yes, sir.
What submission you can have for DEC?
Sir, we have to upload the screenshots of the output, sir.
Most of the output has to be done during the lab now.
Hello, sir.
Screenshot must have done during the lab itself.
Sir, your voice is breaking, sir. Sir. Hello. Hello.
Hello, am I audible now?
Yes, sir. Yes, sir. You're audible.
Yeah. What submissions you have now?
Sir, we had to send the output screenshot, sir.
Those things you would have done during the lab time.
No, sir. Ma'am said to resubmit in Google Classroom.
resubmit. ನೀವು ಒಂದ್ಸತಿ ಮಾಡಲ್ವಾ? ಎಷ್ಟೊತ್ತಿ ಮಾಡ್ತೀರಾ? I know what you are doing.
Ma'am said, sir, yesterday.
I will just talk to her, find out okay why you have to resubmit or ಎಲ್ಲ ಕಾಪಿ ಹೊಡೆದಿದ್ರಾ?
No, sir.
Then
Sir, we have mailed it, sir, last time.
then if you have the if you have the soft copy, just put the same in your what is that Google Classroom account and send it. Why you have to again redo it?
Sir, sir, we are not getting where that was saved in our system, sir. So we are redoing.
Again, Raman, you. Is it the case with all of you?
No, sir.
How many of you have such case? Okay, where you have to redo it? When you do something, you have to keep it, have a different file name for that. You need to preserve it. Okay, how the labs are going now? Now, how do you feel about Tinkercad using the Arduino thing? Okay, accessing what is that? Labsland, accessing remote lab. What is your mood? Are you all scared? Okay, let us go to Shavani. Scared? Confident or what?
Not so scared, sir.
Not scared? How about confidence level? Could you able to do something? Suppose, no, because we want to have a test maybe next week.
Yes, a little bit confident, sir.
Okay, so we'll have the test next week. Done? Is it done? Still next week means another 5-6 days are there. Sonia ji? Enjoying the lab?
So the labs are going good, but I get a bit scared when I do the programs and all.
Why you have to get scared? You need to be happy now.
So it's very new to us now, sir.
Everything is new to someone, okay, for the first time. It is not new. It's already so many days, no? So many weeks. Keep doing it. Keep doing it. It will become.
Much time to adjust. We take much time to adjust, no, sir.
Or adjust what? No, you're all there at your home now, so you should be get
Yes,
adjusted.
sir.
Yes, sir.
Mate?
Many a times we face network issues also, sir, along with this.
See, that's why we have shared the videos. You can able to see the programming, and then it's not, you need not have to depend on only on us. This Python programming, this Arduino program is there. Tons of data is there in your Google. If you mind your time, hello. If you mind it, you can easily understand all those things. Of course, we are not going for a very hi-fi interface. So we are simply reading digital value, writing digital out, analog out, just analog in and digital in. So it is not that complicated. So we didn't go to two hi-fi things. Is program baridira other than okay what is discussed in the class? Not a single extra. Sir, at least idike time illa antira. Am I correct? Sonu Bhatt?
Yes, sir. Am I audible, sir?
You are. What are the extra programs you written?
Not written any, sir.
Why? Is there anybody asked you not to write? You have to write only the thing that is what is done in the class?
No, sir.
Then? Sumana? Sumana BM?
Yes, sir.
How many programs you have written other than what we have discussed in the class?
I have not written any, sir.
Not thinking also.
Sir, I'll try.
Not you will try. You have to, all of you have to write it. Okay, let me just give some task. So how many of you done that? Okay, what is that? Have I given the traffic light control? Anybody tried? Traffic light. I think maybe for your batch, okay, anybody can do it.
Yes, sir.
ಹಾಂ ಏನು ಟ್ರಾಫಿಕ್ ಲೈಟ್ ಏನಾಯಿತು? ಟ್ರಾಫಿಕಲ್ಲಿ ಜಾಮ್ ಆಗಿಬಿಟ್ಟಿದೆಯಾ?
No, sir. ಅದು 2 ways ಗೊತ್ತಾಯ್ತು ಸರ್. 4 ಹೆಂಗ್ ಮಾಡೋದು ಗೊತ್ತಾಯ್ತು ಸರ್.
ನಾ ಮಾಡಬೇಕಪ್ಪ. ವೆನ್ ಯು ಕ್ಯಾನ್ ಏಬಲ್ ಟು ಡೂ ಇಟ್ ಫಾರ್ 2 ಫಾರ್ suppose the engineers like you people, if you struggle, then the other 2 roads they have to be staying there itself, so they cannot move at all.
Yes, sir. I will do it by today, sir.
Have you seen there is an LED with 4 terminals?
Yes, sir. That one I used.
Okay, what is that?
BGR.
Yeah, what is that? Okay, others anybody tried that? Okay, 4 terminal LED. ನೋಡ್ರಪ್ಪ ಅದ್ರಲ್ಲಿ ಏನಿದೆ ಅಂತ. ನೀವು ಹಿಂಗಾದ್ರೆ ಆಗಲ್ಲ. You have to be on your toes. ನಾವು 1 ಹೇಳೋ ನೀವು 10 ಮಾಡಬೇಕು. ನಾವು 10 ಹೇಳೋ ನೀವು 1 ಮಾಡೋದು ಎಷ್ಟು ಆಗೈತೆ. Okay then, bye.